Perfect. So guys, today what we're going to do is we are going to carry out the chemical formula and solubility lab. If you have not yet watched the introductory video for this lab, please don't try to do this without watching that first. You need the context and the explanation from the introductory screencast in order for this to make any sense to you. So if you haven't yet taken the time to watch that introductory video, please stop this, go back to our website and access the introductory screencast. Watch that from front to back, from beginning to end. Make sure that you have the context for how this lab works, and then come back and start this video again. But assuming that you've already done that, we are going to turn our attention to the lab bench, and we're going to grab our 2 sets of salt solutions, and we're going to get started. We actually have 2 sets of salts, both of which are dissolved in water. Set number 1 of salt solutions we'll start with first, and then we'll come back and we'll do set number 2. So as you learned, all that we're going to do is we are going to start grabbing bottles out of this set. So the first set that we grabbed, or the first salt that we grabbed, was Na2CrO4. So what we need to do is we need to figure out what the 2 ions are in this solution. And so when these things dissolve into water, they break into a positive ion and a negative ion. So when this dissolves, our positive ion is Na. There happens to be 2 of them, but our positive ion is Na. Our negative ion is CrO4, which is called chromate, and that's a -2 charge there. So what we're going to do is we're going to take that information and we're going to bring it over to our data chart. This is group number 1, and looking at bottle number 1, and again, it doesn't matter what order we grab the bottles, bottle number 1 has a positive ion, Na, and then the negative ion is CrO4, and that has a -2 charge. And so you'll record this in your data as well. Now we grab our second bottle, doesn't matter which one we grab. This one is Na and NO3. So we have NaNO3. When this breaks in half, we end up with Na, which has a positive charge, and then NO3, which is nitrate, which has a minus charge. So our Na is our positive ion, and then our NO3 is our negative ion. Now notice here that we have bottle number 2 here, but we also have bottle number 2 there. So this would also be Na and NO3. And this third bottle is BaCl2. And when this dissolves in water, our positive ion will be barium with a +2 charge, and our negative ion is chloride. Notice that there's 2 of them, but we only need to know the type of ion in solution. So our bottle number 3 is barium with a +2 charge, chloride with a -1 charge, and then you'll notice that we write this twice as well for bottle 3 and bottle 3. Now we grab our next bottle, and here we have BaNO3(2), which is barium nitrate. Breaking this in half, our positive ion is barium, and our negative ion is nitrate. And there happens to be 2 of them, but we just need to know the identity of the ion. So this would be barium, and our negative ion is nitrate. And again, we will write this twice as well. Okay. Grabbing our 5th bottle, we have KCl. It's not KCI, it's KCl. When that splits in half, our positive ion is potassium, and our negative ion is chloride. So we come here, and we have potassium, and we have chloride. And grabbing our last bottle, we have another chromate. This is potassium chromate. And when we break this in half, this dissolves into 2 potassiums and 1 chromate. So those are our ions. Oh, I forgot to write bottle number 5 twice. This is K, and this is Cl. And then here for this last bottle, our positive ion is potassium, and our negative ion is chromate with a -2 charge. Okay, so now as you learned in the introduction to the lab, we are now going to carry out all of these reactions, and what we're looking for as we do this is the creation of what is called a precipitate. So what we're going to do is we're going to react bottle 1 with 6, 5, 4, 3, and 2. So to do this, our bottle number 1 is our potassium chromate, and we're going to work our way across. And the first one we're going to do is bottle number 1, potassium chromate with bottle number 6, sodium chromate with bottle number 6, potassium chromate. So we are going to fill these half full, and we'll go sodium chromate. And then we'll do potassium chromate, and we are looking for a precipitate. You can see that that well is still clear. It's yellow, but it's clear, which means that no, we did not form a precipitate. Now moving across to our next one, we're going to take bottle number 1, which is again sodium chromate. And we are now going to react this with bottle number 5, which is potassium chloride. And when we do that, you'll notice that this also is clear, and as a result, that did not form a precipitate. Now for our third reaction, we're again going to take bottle number 1, which is our sodium chromate, and we are now going to mix this with barium nitrate. Notice that when we do, this is no longer clear. It creates a cloudy solid, which we call a precipitate. And so this one did in fact precipitate. Now for our next reaction, we're going to take our sodium chromate, place it in the well, and this time we're going to react this with barium chloride, like so. Oh boy. And you'll notice that this also created a solid, which causes the mixture to no longer be clear. So that also formed a precipitate. And now our final reaction in this set will be our sodium chromate. And we will mix that sodium chromate with sodium nitrate. And you'll notice that in this case, it continues to be clear, meaning that we did not form a precipitate. Okay, now moving down to our next row, we have sodium nitrate, and we will mix that with potassium chromate. So we have our sodium nitrate, and we will mix that with potassium chromate, which is this guy. And you'll notice that this well here is also clear, meaning that we did not form a precipitate. So that's a no. Then our next reaction will be sodium nitrate. Sodium nitrate. There we go. Sodium nitrate. And we will mix that with potassium chloride. And that is clear and colorless, meaning that we did not form a precipitate there either. Our next combination then will be sodium nitrate. And we will react that with barium nitrate. Like so. And notice that that is also clear and colorless, meaning we did not form a precipitate. And then finally, we are going to go sodium nitrate, and we are going to react that together with barium chloride. And that also remained clear and colorless. So we did not form any precipitates in that set of reactions. Now we're going to come down to barium chloride. So now we're going to come to barium chloride. And with the barium chloride, we are then going to react that with potassium chromate. That would be this guy. And when we do, you'll notice that we created a milky yellow-white substance. That is our precipitate. So that would be yes. Then our next one will be barium chloride. And we will combine that with potassium chloride. And again, that remains clear and colorless, so that did not form a precipitate. And then finally, we will take our barium chloride, and we will mix the barium chloride with barium nitrate. And you'll notice that that did not form a precipitate either. It is clear and colorless. Okay, so now we're moving down to this row, and here we're going to take barium nitrate. And we're going to take our barium nitrate, and we are going to mix that with potassium chromate. And you'll notice that when we do, again, that becomes cloudy, indicating that we formed a precipitate. So that would be a precipitate. And then the final one in this row would be barium nitrate. And with the barium nitrate, we are going to react that with potassium chloride, which is right here. And you'll notice that that remains clear and colorless, indicating that we did not form a precipitate. Okay, we've got one more to go, and that is potassium chloride off here, and we'll just stick it in this well. So we've got potassium chloride, and we're going to react that with potassium chromate. And when we do, you'll notice that that remains clear, yellow but clear, meaning that we did not form a precipitate. Okay, so we are now done with set number 1, so we can move this off to the side, and we are going to carry out exactly the same process with set number 2. Okay, so now moving on to set number 2. And again, we are going to grab bottles somewhat at random, and we're going to figure out what's in these. So the first bottle that I'm going to grab is CONO32. So breaking this apart on paper, we have CO and NO32. When this breaks up, we get 1 cobalt, which has a +2 charge, and then we end up with 2 nitrates, both of which is -1. So for bottle number 1, our positive ion is cobalt, and our negative ion is nitrate. So now we'll grab bottle number 2, and this is a long one, Cu. This guy, which is copper 2 acetate. Break this in half. Copper is our positive ion, and then acetate is our negative ion. And again, there happen to be 2 of them, but all we want is the identity of the ion. So here, copper +2 is our positive ion, and then this is a little bit of a squeeze. Acetate is our negative ion, and then similarly here, we have copper, and we have acetate. Okay, so now grabbing our next bottle, our good friend table salt, break that in half, and our positive ion is sodium, and our negative ion is chloride. Writing that up here as well, we have sodium, and we have chloride. Grabbing our next bottle then, we have K and OH. These break here. Our positive ion is potassium, our negative ion is hydroxide. So we go K and OH, and K and OH. Now grabbing our next bottle, we have Na and OH, and when that breaks apart, you get positive sodium and negative hydroxide. So positive Na, negative OH, positive Na, negative OH. And then our final bottle is cobalt 2 chloride, COCl2. When this breaks in half, you end up with a positive cobalt and 2 chlorides. So our ions are then cobalt, the +2 charge, and chloride with the -1 charge. Okay, so now we are ready to react all of these guys together. So we're going to work our way across the first row, and we're going to start with cobalt nitrate. And we're going to put some cobalt nitrate in well number 1. And then we're going to take some cobalt chloride, and we're going to mix these together. And you'll notice that it remains kind of that reddish pink color, but still clear. That did not form a precipitate. Okay, so now we're going to take some more of our cobalt nitrate, and we're going to mix that together with bottle number 2, which is sodium hydroxide. Oh my. You'll notice that not only did that go from clear to opaque, it also changed colors. We created that deep purple blue precipitate, which definitely indicates the presence of a precipitate. Now we come back over here to our cobalt nitrate, and to that we are going to add potassium hydroxide. And you'll notice that our results are similar, that again we got that deep blue purplish precipitate, so that too created a precipitate. Then we're going to come back to our cobalt nitrate, and to the cobalt nitrate we're going to add some sodium chloride. Notice that that remains clear, meaning that it did not precipitate. And then our final combination will be the cobalt nitrate, and to this we will add the copper 2 acetate. And you'll notice that this is purple in color because of the combination of the red and the blue, but there is not a precipitate in this one. I don't know if that comes through on
it's kind of hard to tell.
Yeah, so this did not precipitate. The color that we see there is just a mixing together of the blue and the pink, creating purple, but there is not a precipitate that formed there.
You can kind of see it in the comparison between the others that formed the precipitate.
Yeah,
but,
absolutely. Okay, so now we're going to move down to our second horizontal row, and these are going to be our reactions with our copper 2 acetate. So we've got copper 2 acetate. To that we will add our cobalt chloride. And similar to the one that we did previously, while this did turn purple because of a mixing of the colors, it did not precipitate. Okay, so now we're going to take our copper 2 acetate, and to that we are going to add sodium hydroxide. This may not transfer well on the recording, but that did in fact precipitate. There's a solid that formed in the bottom of that, so this did in fact precipitate. So then moving to our copper 2 acetate now with our potassium hydroxide. This too created a solid that's in the bottom. It's no longer clear. And so this too did precipitate. And then looking at our last combination here, we've got our copper 2 acetate, and with that we are going to react sodium chloride, and this is still clear, so that would not be a precipitate. Okay, so now we're going to do our set with sodium chloride as our starting bottle. So sodium chloride here. Mix this with the cobalt 2 chloride, and that did not precipitate. It remains clear. Looking then at our sodium chloride and mixing that together with our sodium hydroxide, that is actually clear and colorless, so we have no precipitate there. And then finally our sodium chloride, and we will, oh, sorry, that was sodium hydroxide. Our sodium chloride, and we will mix that together with potassium hydroxide, and that too remained clear and colorless, so we did not generate a precipitate there. Okay, so we have 3 more to go. Our next one will be potassium hydroxide, and to our potassium hydroxide we will add cobalt 2 chloride, and again we get those deep blue purple chunks. That is definitely a precipitate there. And then we've got potassium hydroxide, and to the potassium hydroxide we'll now be adding sodium hydroxide, and that remains clear and colorless. Clearly we do not have a precipitate there. And then our last combination will be sodium hydroxide, and we'll just do this over here. So we've got our sodium hydroxide, and to that we will add our cobalt 2 chloride. And again, here we get those deep blue purple chunks, indicating that we did form a precipitate. Okay, so at this point, if you were in lab, we would be dumping all these samples in the waste beakers in the back of the room, and we would clean up, and then it's time to start doing your calculations. In order to better understand how to carry out these calculations, you'll probably want to refer back to the introduction screencast that lays out for you how to carry out the calculations specifically. If you have questions, please email or contact your teacher. Understand that within this lab sheet, there is more room than you need. So you will not be filling up all of the calculations table with your calculations. But please spend the time to work through these carefully. Again, if you have questions, ask. And when you're done with that, answer the conclusion questions. And you are done writing up the solubility lab. Thanks for your time.